I'm going to show you how to solve the problems on the Algebra 2 Mid-Year Review worksheets that I gave you in class. I'm going to go through these problems not really slowly, so if you need me to slow down or if you need to stop, just pause the video. I'm hoping that you get a chance to try each one of these on your own before listening to me solve them for you, because you're going to have to do this yourself on the day of the midterm. And if you don't go through those mental exercises of trying to figure out what to do and then going and doing them yourself, then you're going to have a lot of trouble on Monday when you actually do have to go through these yourself. So what I would do, if this were my worksheet, I would try all of these problems, or try one and then listen to this video and then see if you got the right answer in the end. So here we go with number 1. I have to multiply by the conjugate of the denominator, square root of 17 plus 3, over the square root of 17 plus 3. The numerator, you distribute. Well, you don't have to distribute. You just write 4 times the square root of 17 plus 3, put them together. And in the bottom, the square root of 17 times the square root of 17 is 17. And negative 3 times positive 3 is negative 9. 4 times the square root of 17 plus 3, all over 17 minus 9 is 8. 4 and 8 are factors. Factors reduce to 1 over 2, so the final answer is the square root of 17 plus 3, all over 2. Question number 2. When you square a binomial, it means you have to FOIL. 2 plus 3i times 2 plus 3i. FOIL says we've got 4 plus 6i plus 6i plus 9i squared. These two combine into 12i. Plus 9i squared is minus 9. 4 minus 9, combining like terms into negative 5, plus 12i, and you can't combine those any longer. Negative 5 plus 12i. Number 3, you multiply the top and bottom by the conjugate of the denominator, 2 plus 3i, over 2 plus 3i. The top has to be FOILed. 12 minus 18i plus 6i, all over 4 minus 9i squared. Oops, I'm sorry. I didn't do the last. 3i times 3i is plus 9i squared. FOIL. Oops. Here we go. FOIL the top, F and L the bottom. A positive 9i squared turns into negative 9. Negative 18i plus 6 turns into negative 12i. A negative 9i squared turns into a plus 9. So what we have left with is on the top 12 minus 9, which is 3, minus 12i on the top, and 4 plus 9 on the bottom, which is 13. So there's the answer to number 3. Number 4, large powers of I. Well, I squared is negative 1, so this is 3 times negative 1. I to the 4th, you have to divide by 4 and get a remainder. 4 divided by 4 has a remainder of 0, so this is 2 times I to the 0. When you divide 23 by 4, 4 goes into 23 5 times, but has a remainder of 3. So this is 5 times I to the 3, the remainder. 3 times negative 1 is negative 3. I to the 0 is 1. 2 times 1 is 2. And I cubed is negative I. So what we're left with is negative 5 minus 5i. When you have a complex fraction, you find the LCD. The LCD is a squared. Multiply everything by a squared. All 4 terms. 1 times a squared is a squared. This a cancels out with one of those. So you have a squared minus a on the top. A squared times 1 is a squared, and those a squareds cancel out on the bottom, minus 1. Then you take the GCF out of the numerator, which is a, and you're left with a minus 1. And in the denominator, difference of two perfect squares factor is a plus 1 times a minus 1. Common factors cancel, and the final answer is a over a plus 1. Number 6, factor everything possible. Factor out a 3x out of the bottom, and you're left with x minus 2. This is a factor in, factor out, so 2 times 2 is 4. Factors of 4 are negative 4 and negative 1. So we have 2x minus 4 times 2x minus 1, all divided by 2. So with factor in, factor out, I'm going to bring this fraction down here, 9x squared on the top and 3x times x minus 2 on the bottom. The factor in, factor out result was x minus 2 times 2x minus 1. In this denominator, there's a 3 GCF, so pull them out. 3 times 2x minus 1. 2x minus 1's cancel. X minus 2's cancel. One of these two x's cancels with each other. So this x squared becomes an x to the first, and this x cancels here. 9 over 3 reduces down to 3 over 1. And this 3 and this 3 will both cancel out. So it looks like we've crossed every single thing out, so the answer is 1. When everything cancels, you're just left with a 1. Number 7, all of these are negatives underneath the radical, so they're all i's. So I'm going to pull out the negatives and call it an I. 45 breaks down to 9 times 5. 20 breaks down to 4 times 5. 10 does not break down. So this is 2i times the square root of 9, which is 3, which is 6i square root of 5. Square root of 4 is 2, so 2i square root of 5 minus I square root of 10. And then these two can combine into 6i plus 2i is 8i square root of 5. Those are like terms, but the I square root of 10 is not a like term. So that just stays by himself. Cannot combine anymore. These square roots, this is a square root. Well, 27 has a perfect square of 9 times 3. X to the 9th breaks down to x to the 8th times x to the 1st. And y to the 12th just stays as y to the 12th because it's an even exponent. So the 9 gets taken out and is called a 3. The x to the 8th gets taken out and is called x to the 4th. The y 12th, you divide 12 by 2 because there's an invisible 2 here, which becomes y to the 6th. And then what we got left underneath is a 3 and an x. I'm going to use my calculator to evaluate this one. What it really means is substitute j equals 4. So if I wanted to expand this out, it would be 4 squared minus 2 times 4. You're going to add to that j equals 5. 5 squared minus 2 times 5. Add to that 6 squared minus 2 times 6. And add to that 7 squared minus 2 times 7. And you can plug all these into your calculator if you want. All we did was substitute 4, 5, 6, and 7 in for those j's. And you're going to add those terms up. But on my calculator, I can hit alpha window, option 2. And if it doesn't get stuck, like it did, I guess I'll have to use another calculator. Alpha window, option 2. X is equal to 4 up to 7 of x squared minus 2x. And that'll give me an 82. If I added all those up, it's equal to 82. Now I want to plug in a 4 in for those x's, so it's 1/2 times 4 squared minus 4 to the 1/2 minus 3 times 4 to the 0. Plug in 4 for x. So 1/2 of 16 is 8, 4 to the 1/2 is 2, and 3 times 1 is 3. And minus 2 is 6, and 6 minus 3 is 3. Set C. We're going to solve for x. This is a quadratic, so you have to subtract 2x from each side and set it equal to 0. So there's two different methods we can use. We can do a complete the square, x squared minus 2x plus blank. Move the 5 over and call it negative 5 plus blank. Half of b squared is 1. And so we have x minus 1 squared equals negative 4. Take the square root of each side. X minus 1 is equal to the square root of negative 4. You have to put a plus or minus, is 2i, because it's a negative underneath the radical. Add 1 to both sides, x equals 1 plus or minus 2i. So those are the answers. That's complete the square. The other method, we could say the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c is 20, all over 2a. That's quadratic formula. 2 plus or minus the square root of negative 16 over 2. 2 plus or minus the square root of negative 16 is 4i over 2. And now we can just reduce each one of those down. 2 over 2 is 1, plus or minus 4i over 2 is 2i. So you get the same answer using two different methods. Number 2, you can add 1 to both sides to isolate that radical, and you get 4x plus 8 equals x. Negative 2 plus 1 is minus 1. And you have a square root of that. So now to get rid of the square root, you square both sides. So you got 4x plus 8. X minus 1 squared is equal to x minus 1 times x minus 1, which is a FOIL. After you get done foiling that, you get x squared minus 2x plus 1. This is quadratic, so you set it equal to 0 by subtracting 4x and 8 from each side, and you get 0 is equal to x squared minus 6x minus 7. This factors into x minus 7 times x plus 1. So x is equal to 7 and x is equal to 1. And now I'm going to check to make sure that they work. I think I'll just use my calculator. I'm going to have 7. Oops, that calculator doesn't work. I'm going to have 7 stored in for x. And I'm going to see if the square root of 4x plus 8 is equal to x minus 2. And it doesn't seem like it works. Now I'm going to store 1 into x and see if the square root of 4x plus 8. Looks like neither of them work. I think I might have done something wrong here. I'm going to pause this for a second. All right, I found out my mistake. So x equals 7 and x equals negative 1 over here. So what I didn't do was I didn't check in the original equation. The original equation said 4x plus 8 minus 1. And is that equal to x minus 2? And they're both equal to each other. So 7 checks. So 7 is one of the two answers. And I'm going to store negative 1 into x. And I'm going to see if, by just popping up there, see if that works. And then x minus 2. And the left side equals 1, the right side equals negative 3. So that does not check. So x equals negative 1, dnc does not check. So there's only one answer to this question, number 2. X equals 7. Number 3. This is a fractional equation. So you have to find what the LCD is. Factor this into x plus 2 times x minus 2. And so the LCD is x plus 2 times x minus 2. So you're going to multiply everything by x plus 2 times x minus 2. This is called clearing the denominators. Everything, both sides of the equation. So the x minus 2's are going to cancel, and you're left with 3 times x plus 2. The x minus 2, x plus 2's cancel, so you're left with 8. And over on the right-hand side, x plus 2 times x minus 2 is x squared minus 4. I'm going to distribute the 3, 3x plus 6 plus 8 equals x squared minus 4. I'm going to combine 6 and 8 to 14. And then, because this is quadratic, I'm going to set it equal to 0. So you subtract 3x and subtract 14 from each side. And you get 0 on the left. X squared minus 3x, negative 14 minus 4 is negative 18. And this factors into x minus 6 times x plus 3. So x equals 6 and x equals negative 3. Well, let's see what x cannot be equal to. Up at the very beginning, x cannot be equal to 2, because that would make that denominator equal to 0. And x cannot be equal to negative 2. So both of those answers are not in my list of cannot do. So we have two answers to this question, 6 and negative 3 both. Number 4, 3 to the 2x equals 27 is 3 cubed to the x minus 1. So you're going to distribute that exponent. 3 to the 2x is equal to 3 to the 3x minus 3. The 3's don't matter anymore. 2x equals 3x minus 3. So if you subtract 3x from each side, you get negative x equals negative 3. So x is equal to positive 3. Number 5, absolute value equations. You're going to say 3x minus 4 is equal to 5. Oops, I should have given myself a little bit less space. Equals 5, and 3x minus 4 is equal to negative 5. So positive and negative. So we're going to add 4 to each side. 3x equals 9, so x equals 3. And adding 4 to both sides here, 3x equals negative 1, or x equals negative 1/3. And when I plug this into the original equation, does the absolute value of 9 minus 4 equal 5? Well, yes, that checks. And over here, 3 times negative 1/3 is negative 1. Negative 1 minus 4 is negative 5. And the absolute value of negative 5 does equal 5, so both of those check. We have two correct answers. Number 6, you have 2x minus 4 less than 6. And 2x minus 4 greater than negative 6. Two branches. Add 4 to both sides. 2x equals 10. Or, I'm sorry, is less than 10. Or in other words, x is less than 5. Over here, add 4 to both sides. 2x is greater than negative 2, so x is greater than negative 1. This is an and. So, because it's an and, we have a negative 1. A 5, we have open circles, and we have shaded in between. So we have symbolic. Symbolic is negative 1 is less than x is less than 5. Symbolic. This is graphic. And in interval notation, you have negative 1, comma 5. Interval notation. So you have the three ways of representing it. Number 6's answer. Number 7 is a quadratic inequality, so you factor x minus 6 times x plus 4. We're going to find the critical values, 6 and negative 4. We'll put that on a number line, negative 4 and 6. These are filled in circles because it's greater than or equal to, and greater than or equal to is an or. Ors are shaded on the outside. So there's your graphic representation. Your symbolic is x is less than or equal to negative 4, or x is greater than or equal to 6. Symbolic. And then in interval notation, you have negative infinity, comma, negative 4 with a square bracket, or bracket 6, comma, infinity, rounded. That's interval notation. On number 8, you're going to divide each side by 2 first. You have x minus 1 to the 3/4 equals 8. You're going to raise each side to the reciprocal of that, which is 4 over 3. So x minus 1 gets raised to the first power, and 8 to the 4/3 is the cubed root of 8, which is 2, and 2 to the 4th is 16. Add 1 to both sides, x equals 17. And when you plug 17 in for that,